Okay, let me give you a quick tutorial on the lab today, the lab you're going to do this week for flooding. So I introduced some of the terminology in the lecture portion, and that is recurrence intervals and probabilities. So the formulas are here, an example of how to do it. But one of the things that we need to do prior to doing the calculations is you need to rank. So remember, I'm giving you some data here. You need to rank these from highest to lowest. And so all you're looking at is the cubic feet per second, finding the one that has the largest of these values and giving it a 1, and then going all the way down to what, 10, 1, 2, 3, 4, 5, 6, 7, 10, right? So then you're going to use that to identify what ranking you gave this particular flood, plug it in the formula, and it'll tell you the recurrence interval. So don't get too confused by that. You need to rank them first. Use that number. The ranking number, remember, is the M, right? That's going right here. The number of years is given to you. So you should have all the information you need to make the correct calculation and figure out the recurrence interval. Probability is just a formula. Follow the formula. Calculate a few more of these. So we're going to have you do it a couple times. Then it's talking about a discharge. So remember, we covered that as the amount of water that a stream can produce, right? So what we're asking you to do here is to calculate the amount of water that a stream might produce given some parameters. And so some of those parameters would be the velocity, okay, how fast the water is moving, and the width and the height of the stream channel itself. So you're just doing a simple calculation to figure out what that might be. Now, based on the parameters of the stream, asking you if some of the parameters were different based on the value that was coming out. So if this was the value, I changed some of the parameters, which one of these would indicate that the stream would flood? So remember, we're giving you a specific width, how wide the stream is, and a particular height, which means it can only hold so much water. And so if we change some of the parameters, which one would cause it to flood? That's kind of what this question is asking you to puzzle out. Then we talked about drainage basins in the lecture. Also, here is an example of a drainage basin, letter K here, and it is part of a map. And so this is in the McDowell Mountains. What I'm asking you to attempt to do is to measure how big is this area. It's as close to a rectangle as we could find. So we're going to use that formula, just length times width, the average. Measure from like here to here for the length, here to here. Here's the scale. So, okay, it's on a computer screen. I get it. I know it's not the most convenient. But a quick little trick is to take a piece of paper, put the edge of the paper right here on the 0, and then put a mark right here at 1 and a mark right here at 5. And then bring your paper up and see how wide is it and how long is it. Estimate it within a quarter of a mile, right? So you should get two values, you multiply them together, and voila, you know the square miles. We just need to convert that to acres so that we can use that information later on. You're also going to look at the map and figure out the contour interval. So remember, all that is to look at, scroll, scroll, scroll. Oops, got a little carried away. To look at my map here. And remember, these values tell you the elevation. I want to know what each and every line represents here, so you can calculate the contour interval. And then we need to know how steep the stream is, right? What's the gradient? So that is, I need the elevation at this point A, the elevation at this point B. So that's part of the information I need. So we'll calculate that. Then I need to know the distance. We use that little piece of paper trick that we use to figure out length and width and put it along the stream, along the stream, along the stream, and estimate its length. Using those two values, you should be able to calculate a gradient, right? So it's the change in elevation divided by the distance that you just calculated, okay? So you can do that, get a gradient, and then we can figure out the slope percent. We need all these values because there actually is a way to look at a drainage basin and look at the properties of the drainage basin and evaluate how much water can come out of that drainage basin. And so what we do is we look at these criteria: the relief, which means how steep it is; soil infiltration. What does that mean? If there's a lot of soil, water will sink into the soil and not get into my stream, so it won't produce as much water. But if there's no soil, a lot more water gets in my stream and it produces a lot more water. The same with vegetation. A lot of vegetation absorbs water, less goes into my stream. Less vegetation, more in my stream. And surface storage has to do with steepness. And so if you look at the map and you see these big lakes and ponds, that means that water can flow into those features instead of my stream. But if there isn't any, we would argue that more water gets into the stream. So you're evaluating whether you think the relief, the soil, the vegetation, the surface storage is extreme, high, normal, or low, and then you would assign it one of these values in the parentheses. So you did do the percent slope, which you can use to evaluate relief, and then I give you some explanations or tips about what each part of the drainage basin does, right? So soil infiltration, based on this, what number would you give it? Based on the fair to poor coverage, what number would you give it? So you want to pick out all those numbers, and then you're going to add them and get a total number which represents the characteristics of your watershed or drainage basin. The reason we need that is this crazy graph actually tells us what the amount of water, the discharge we can expect our stream to produce. And so believe it or not, this is what some hydrologists would do to evaluate a flood hazard. You want to go out and look at your drainage basin. What is it supporting? How much water is it pushing into my stream? A lot or a little? Depends on its characteristics. So you now know the drainage area in acres. You do that calculation. That's the value that's at the bottom here. The number that you added up all the characteristics is here. And so in order to figure out what drainage discharge is, you come over here and you say, oh, was my drainage area 1,000? Okay, so I'm going to follow the 1,000 line straight up. And what was my characteristic values? Was it 24? I'm going to come down at an angle until I hit my 1,000 line, which is right there. Now I come across horizontally, and this is the amount of discharge that that stream will produce based on the area of the drainage basin and the characteristics of the drainage basin. If it did end up at this point, we would estimate it to be maybe about 1,800 cubic feet per second. That's how you're going to use this chart. Use your drainage area that you calculated in acres, use your total characteristics, diagonal for the characteristics, straight up for the acres. Where they meet, go across and read the value off from there. And then you'll know how much water's coming out of your stream. So what this is saying is, if this is my stream and it has these characteristics, right? This width, this depth, and this amount is coming out, is it going to flood? Well, you know the formula for figuring out what this can handle, right? Width, depth times velocity will tell you what that particular stream can handle. Can it handle 5,000 CFS or only 2,000? If your value here is greater, then it's going to flood because it can't handle it. But if it's less, it won't flood. So that's kind of the idea, that these little things can be a little challenging, so don't let them confuse you. And I know there's a lot of numbers here, but it's just some multiplication, a little division, so don't get too crazy on me. So if you have any questions, of course, I can't speak today, please feel free to contact me as always. And good luck.